But there will be future competitors, like the Russian Sukhoi 37, which features thrust vectoring and a radical forward swept-wing design. And the fifth-generation MiG, the 1.22, which some have nicknamed the F-22ski.
The Russians are still very active aircraft developers. They've got a variety of technologies that they're continuing to improve upon and that can be made available to our future enemies. And so that's why we have to stay on top of the technology that we are developing and make sure that it is able to take out anything that other countries develop.
When you look at the adoption by China of the Su-27 and the fact that it'll probably be modernized and improved, that brings up the need for more advanced fighter aircraft in the US. And that's one of the main reasons, I think, why the Air Force is so insistent on the need to have the F-22.
In addition to Russia, other US allies are producing advanced interceptors for export that are superior to the F-15, such as Sweden's JAS-39 Gripen and France's new Rafale. Germany, Italy, and the UK have joined forces to create a Eurofighter, the Typhoon. If these planes fall into unfriendly hands, the US Air Force will need the F-22 to maintain their advantage.
We're always going to go into war wanting to have that air dominance, and the F-22 is going to be the big boy on the block that can help us to do that.
In future combat, the F-22 is to be joined by another stealthy aircraft, the F-35 Joint Strike Fighter, the ground attack bomber of the future. Designed for the US Air Force, Navy, Marines, and Britain's Royal Navy, the question is, will it work for every user? The rules of war have changed. Brute force has given way to high tech, and conventional weapons of the past will no longer be effective. In future battles, the F-22 will be the first fighter to cross enemy lines, surgically removing air and ground targets. Next in the F-35 Joint Strike Fighter, the attack bomber of the future. It will assume the air-to-ground attack role for the US military. The F-35 can carry heavy weapons externally for maximum effect. But when a smaller payload is carried internally, it is nearly as stealthy as the vaunted F-117 Nighthawk.
It has a significant amount of stealth capability to allow it to be used early on in a campaign, and it has a significant amount of weapons carrying and payload capability to be used at the later stages of campaign. The threat to the airplanes may not be as significant and require less stealth.
The development of the F-35 was driven by the Armed Forces' desire to save costs by creating a ground attack bomber that would meet the needs of the Air Force, Navy, Marines, and Britain's Royal Navy.
Airplanes are becoming very expensive these days, and we had to do something to get the cost of these airplanes back down to a reasonable level.
The F-35 is expected to cost about $40 million, one-third the cost of an F-22 Raptor. But could one basic airframe be designed to satisfy so many different military demands? Each armed service wanted a stealthy ground attack bomber, but the Marines also needed a plane with short takeoff and vertical landing capability. The US Navy required a craft with larger wings, heavy-duty landing gear, and an arresting hook for carrier landings. And the wings would have to fold up to save deck space.
The size and scope of the JSF program is pretty significant. The airplane is being designed to replace the F-16 and the A-10 for the Air Force, the AV-8B for the Marine Corps, and the FA-18 for the Navy.
Unlike the twin-engine F-22 Raptor, the F-35 Joint Strike Fighter was designed around a single engine to keep down not only costs, but weight. A lighter plane can carry more weapons.
For the Joint Strike Fighter, one of the keys of its mission is the ability to handle a large amount of ordnance and bring it to an enemy site. That all works better with a single engine.
Air Force version of the Joint Strike Fighter, the F-35A made its first flight attempt on October 24, 2000. Tom Morgenfeld, who had been a test pilot for the F-22 Raptor, was at the controls.
Well, a million things are going through your mind. Your eyes are everywhere, you're listening, you're watching. Your senses are tuned to an incredible level because you're sensing and feeling the airplane for the very first time. It flies wonderfully. It's definitely a pilot's airplane.
The Air Force testing went smoothly. Next, a Navy version was built with heavy-duty landing gear and wider wings for the slow speeds needed to land on carriers. Navy test pilots flew touch and goes, demonstrating the F-35's ability to land within the space of a carrier's flight deck. But the most difficult challenge still lay ahead for the F-35 program. The Marine Corps needed a version that could perform short takeoffs and vertical landings, STOVL for short.
The STOVL capability is extremely important to the Marine Corps because the airplane can go just about anywhere that the rest of the forces can go. It's not limited to needing a large runway. It doesn't need a really big ship to operate off of.
Engineers at Lockheed Martin, the designers of the F-35 Joint Strike Fighter, took a hard look at the AV-8B Harrier, the STOVL fighter that the new aircraft would have to improve upon.
The Harrier is a great airplane if you look at the fact that it's basically 1960s technology. It's achieving all those wondrous STOVL flight sort of maneuvers without the aid of a lot of computers.
The Harrier's ability to take off, hover, and land vertically is achieved by vectored thrust. The powerful force of its jet engine is directed downwards through 4 nozzles that can pivot 90 degrees.
I was brought in because I am a Harrier pilot with almost 1,600 hours in that airplane. So all of the lessons learned I have from the Harrier airframe and operational experience I have, I was able to bring to the program and use those to help evaluate the X-35 STOVL version.
For hovering, engineers gambled on a radical new system. They planned to supplement the vectored thrust method by harnessing the jet engine to a drive shaft that would power a fan to blast air downward.
In 1991, we unveiled this shaft-driven lift fan system to the technical world. Some actually said, "You gotta be kidding me. Are you guys serious?"
The lift fan required doors to open behind the pilot on the top and bottom of the plane to draw in more air. The fan would blast air down mid-ship, while the jet nozzle in back swiveled, blowing its powerful exhaust down to create a balanced lift force.
The shaft-driven lift fan system allows you to harness a lot more energy out of what the engine is producing.
But harnessing a jet engine to a drive shaft proved to be extremely difficult.
The mechanical energy we were dealing with in the shaft-driven lift fan system was very large. We had 28,000 horsepower being transmitted from the drive shaft from the main engine to the lift fan. And that's similar to the power going through a U.S. naval destroyer.
The lift fan's ability to blend large amounts of cool air with the hot jet exhaust provided another important benefit.
One of the things we learned in JSF was to combine the jet exhaust to get a lower combined temperature than the Harrier. This allowed us to avoid some of the problems with concrete where the concrete would actually burst and explode under the high temperature and high jet exhaust from the Harrier.
At the Lockheed Martin test facility in Palmdale, California, the revolutionary lift fan system was put to the ultimate test, in the air. If the lift fan failed during hover, the plane would crash.
It made its first flight in 2001, and it was a complete success. And at that time, I didn't hear any more from the people who had been saying for years, this thing will never work. It worked.
Now, all 3 versions of the F-35 for the Air Force, Navy, and Marines are being developed and further tested for mass production. The United States, Britain, and their allies are expected to order more than 4,000 Joint Strike Fighters, which will replace most American-built fighter bombers in use today.
The handling qualities and performance are stunning. Really is a pilot's airplane. It sort of makes you feel like a little boy. You want to take it home and tuck it under the pillow with you at night. It's just a pilot's airplane.